Hey everyone, and my name is Agas, and I am working on the project given by the Trinity. That is the project number 7. As you can see here, the picture is showing us of a car, which really means that we are making some analyzing of the car features based on the price and profitability. So this project description, if we talk about the project description, so we are overview of the projects and purpose is the project aims to analyze how different car features influence the price MSRP and profitability of the vehicles. Like we have the different uh, types of vehicles. So what are all features like suppose that engine horsepower, mileage per gallon. So what is the impact on the profitability and basically the prices of making a car. So the purpose is to assist the car manufacturer in making the informed decisions regarding the pricing strategy, product development, features prioritizing to maximize the profitability. So by analyzing this data set, the manufacturer will be having a clear idea of how to prioritize or manufacturer that could give us ultimately the maximum profit while understanding the demand. So by identifying the key car features that affect price, the manufacturer can optimize its offering to meet the market demand and achieve its better margins. So let us talk about what are the business problems here. So the project address the following business questions, which are example which car features like engine horsepower, engine cylinders, transmission type have the most significant impact on the price of the vehicles. So by answering these questions, the manufacturer will be able to determine which features to prioritize in the production and how to price their cars effectively based on the consumer preferences, right? If we talk about the data sources, so initially our data sources were almost 12,000, and after observations we found some duplicates value. So we dropped and finally we get the data 11,000 clear observation with 16 variables related to the car features and pricing. If we talk about our car key features or the key variables, so we have like make, model, year. These are the basic informations about the vehicles. If you talk about the engine horsepower, engine cylinders, so these are the columns which specified related to the vehicle engines, and people are most interested in which kind of like buying the product of which kind of horsepower or engine cylinders. And while talking about the transmission type, whether the vehicle are automatic or manual transmission. So the MSRP manufacturer suggests that the retail price is corresponding the car price, and this data point allow for comprehensive analysis of the factors that influence the car pricing and profitability. So, what are basically the data cleaning and processing steps taken here? This is So before analyzing the data, the following data cleaning and processing steps were performed, like handling the missing data. We found some rows to be missing values. Example, numerical values found to be in the numerical columns like cylinder, engine, horsepower, number of doors, highway mileage per gallon, which were identified and changed with the mean value. Why we changed? Because if this data were like missing or an outlier, so this going to be skew or analysis, and which we do not want, right? I would highly interested in showing you this thing in my Excel PPT how I did it. So let me just give me a second. Yes, here we go. You can see it here. Like we have some columns like engine horsepower in the column number E, some engine cylinders, number of doors, high mileage per gallon. So these were found to be like empty columns. So what we did here, we changed it with their average value, and finally after getting the average, we using the integer function into the integer value to substitute them. So we found the average value to be, in this case, like just come up, engine horsepower to be 253. So we substitute by the average value. Likewise, we did with the like number of doors or cylinders here. We also change this here like highway mileage per gallon. You can see here highway mileage per gallon is found to be 26, and there are many vacant rows found here. We filled it with that. Let's come back to our presentation. Here we go. So talking about the outlier detection, extreme outliers found in the higher mileage per gallon. So yeah, this is the column where we found that 256 miles per gallon. We actually found it and then adjusted to the mean value because it's like completely unexpected for mileage like high mileage to be 256 for any type of car. So we changed it. If we talk about the next duplicate row data, so I earlier discussed about this. What we did, we found like 800 across the rows to be the identical. That does not make any sense for our analysis, so we get removed them. Let's talk about the approach taken in this project here. So the approach is the first approach like this project, the following analytical methods were used. So first will be the descriptive statistics to understand the distribution of data and get an initial sense of variable. Measures like mean, count, and some were calculated for key features such as the engine horsepower, engine cylinder, high mileage. So next step is various visualization techniques like scatter plot, bar charts, cluster terms were used to identify the trend and the relationship between our variables. For instance, the scatter plots were used to visualize the relationship between the engine horsepower and the mileage per gallon. So these have been used according to how insights required. That will be the best suitable for the stakeholders or our teams. Uh, Further analysis, regression analysis is taken. It is taken a kind of the Excel features. A linear regression model was employed to quantify the relationship between the car features, identifying the variables and the prices. Like variables like all the other columns with the MSRP as the dependent variable. This helps in understanding which features most significant influence and profitability. Let us talk about the reasoning behind the choice of the analytical method. What are the reasoning behind choosing this analytical method? So descriptive statistics helps in understanding the basic structure of the data that identify sensitive tendencies and providing a foundation of the data analysis. Second, the data visualization of course, it's like a story and make it easier for any audience to grab it and understand the trends or patterns or relationships which guided further analysis. For example, a scatter plot shows a clear positive correlation between the engine horsepower and mileage per gallon and justifying the use of the linear regression. So any any stakeholder or any our audience will be able to understand easily the correlation by if he can see or if he or she can see the scatter plot. Third is the regression analysis was chosen to establish how different features impact the MSRP. This method helps in assigning weights to features like engine horsepower, transmission type, and engine cylinders, shows how much each variable contributes to car price. Each variable, how these variables are affecting our car, basically car prices. So for the regression analysis. Challenges and limitations, of course, there have been challenges like finding the missing data, critical fields, number of cylinder, engine horsepower, number of doors, highway miles per gallon, and missing value, and that required imputations. Outlier, high priced luxury vehicles introduce extreme values, potentially distorting the analysis. In highway MPG column, we identified up to 56 miles per gallon using the scatter plots anywhere. This is the Excel file sheet that I have interlinked here. So we can on this to go on the Excel sheet. You can click on this hyperlink and direct it to you either Chrome or any other browser like Firefox, and from there you can download it to see what are the steps taken or how we did the analysis. Take stack use. So let us talk about take stack use. Of course, Microsoft Excel used for the irrigation analysis, calculations, and visualizations, and we are using the latest the reasoning for choice familiarity. Excel is widely recognized and used, making it easier for the stakeholders to understand and duplicate the analysis. Versatile, Excel provides a large consumption of data cleaning and visualization, making it all in one for the project. So these are uses of using the Excel data management. Excel can effectively handle the data set here like 12,000 observations or lower and perform the advanced calculations easily. Additional packages and libraries used. We have been using the data analysis toolpack, which is not, of course, like enabled for all the Excel. So we are using this package or library. We are utilized for performing the statistical analysis like correlation and regression, which help identifying the key factors, identifying the car price and profit. Let us talk about the project description. Just give me a second. I think we are coming to the first page. Here we go. This has been discussed. Yeah. So it's let us talk about our first question. So here in this case, it is popularity of car model across the market categories. So first, I would like to talk about we have been using the pivot table and the combo chart. Description: if we talk, this part involves creating a pivot table to show the number of car models in each market category and their corresponding popularity score. So we have been using, of course, a combo chart is then used to visualize the relationship between the market category and the popularity. This is our graph representing the combo chart, which is we have been using a basically line and column chart. So here the line chart is representing the count of models we are have in each market category, and the yellow or you can say the columns are showing here the average of popularity, right? I'm highly interested right now in showing you how we use the pivot tables and then draw this awesome graph. So here we have market popularity. I think it will be visible. Yeah, okay, very fine. So it is visible here. What I did here, I make it larger. So first, let us talk about the pivot tables. Let me show you. So value field. So what I did is basically you can see on the right side, we have drag and drop the models in the column, and we have changed two values. And in the rows, we have dropped the market category, and then in the values, we like drag and drop model, and then we change it to count of model. And then for the popularity, we did is average popularity, because sum of popularity does not make sense. And while also we actually need the count of models, and you can see that models are not in under, so we are using a count to calculate the count of models. So this is it. And finally, after selecting this data, we have drawn our column cluster column, sorry, a combo of column and line chart. So I make it larger here for our understanding, and also simplified our PPT or presentation. So we can see each here our top three market categories that have the average popularities: high check flex steel, flex steel diesel, and third is the crossover flex steel. And after that, everything is like declining, right? So like cross flex steel performance. After that, like crossover luxury performance hybrid. These they are having the average popularity of 5,657, while the lowest is coming in exotic luxury and some blanks unknown values. Average popularity for the flex fuel hybrid. If we talk about the models, so we can see here it is like we do not have the data set for the max count of model that is not available, but we have a substitute after this. Not a substitute, but this is here, like the crossover. So the crossover is having market category of crossover is having 1075 count of models, and the second number is luxury, which is having 890 models. So these are the models. We will be talking about some of the insights, what insights you can gather from this analysis. So for that, come back to the presentations. So here it is, right? So let us talk about some insights. So after analyzing this chart, we can find maximum and minimum popularity by market category. I have discussed it like hatchet flex fuel diesel, crossover flex fuel performance with the average popularity of 5,657, with counter models being 7, 16, and 6. So with this data, we have that average popularity, if we are having the average popularity, that means we are having quantum models more. No, we are having quantum models less. The popularity is getting higher. The minimum of average popularity belongs from the market category of for performance hybrid average popularity of 1055, flex steel performance hybrid average popularity of 155, with flex steel hybrid with average popularity of 155, and exotic luxury average popularity 122, of with quantum models being 1212, 122, and 12. Let's talk about the maximum or minimum quantum model by the market category. So the maximum quantum model belongs from the market category of the crossover with 1075 models available, flex fuel being the 855 models, luxury car with 818 counter models available. So we can see that market category is focusing on the crossover or the flex fuel, also with the luxury cars, making the luxury cars. And these their popularity are also good or in average speed. That is 1500, 56, 2225 and 1080 respectively. If you talk about the medium quantum model that is coming with the market category of the crossover exotic luxury performance, exotic luxury high performance hybrid, one model available in this like market performance hybrid one. Okay, sure. There is our keyboard is I think yeah, keyboard is yeah, so, not good. So relationship between the engine power and the price. Our second analysis, the we'll be talking about the relationship. What is the relationship between our engine power and price? So of course we'll be using the scatter plot or the scatter chart with the trend line. So here a scatter plot is created to examine the relationship between the engine horsepower and car price. With trend line is added to visualize the correlation between these variables. Because for this is the best suited. The following graph is scatter chart with trend line relationship between engine horsepower and MSRP. This is our graph. So while x-axis is representing us the engine horsepower and y-axis is representing the MSRP of the car. We can see we have an extreme outlier here with the engine horsepower of near 1000, and it's we have I think 2 to 3 extreme outliers here with the prices also being high. And this chart shows us if the engine horsepower is increasing, then the MSRP is also increasing. This is also very practical for being an engine with higher power and with having the MSRP also higher. But here we can see our max models are between like 100 or 50 to 600. Maximum of models are here with the engine horsepower being like 50 to 600, and their prices are also between or lower to the 5 lakhs. Let us come for this in our example view, engine power and price. Yes. So engine horsepower and MSRP. You can see again we have been using a very good pivot table, use of very good pivot table. Let me show it. Just click on. Okay, so on the rows we have been dropping the engine horsepower, and in the values we have been using the average of MSRP. So again, I forget to tell you, yeah, this is another chart like I have been using to find is there any relationship between the average MSRP by engine. So this is that, and this is simply we have drag here like engine horsepower and MSRP. This is the chart, and an exponential linear chart like trend line has been used here, and here we have been using an average trend line chart. This is, but we can also see there is a correlation between these graphs, and these are very similar, right? So this is showing us the average, and this is showing aggregated value without any average. This is showing the relationship between the horsepower and price. Let us talk about some insights. So price tends to increase with the engine horsepower, we have a positive correlation of 0.856, and we found using the Fourier constant this that suggests like when you increase engine horsepower, there will be significant increase in the engine horsepower with correlation something like 0.658. Maximum horsepower is 1001 and with the price 20 lakh 65,902, which is extreme outlier related to the engine horsepower price. Others. So maximum range fall within the engine horsepower of 60 to 600, while the price range fall in between 20,000 to 6 lakh for this one. Third analysis is key feature determining a car prices. So regression analysis and bar chart basically we have been using a regression analysis that task identifies which car features have the strongest relationship with price. The coefficient is visualized in a bar chart to highlight the relative importance of each feature. So the following bar chart is showing the coefficient price with category, while engine cylinders being more positive. If we talk that engine cylinders are the business sides like a strong less positive impact on price, indicating more cylinders lead to higher prices. While the numbers of doors is negatively correlated, suggested that fewer doors command higher prices. Highway mileage per gallon, so like moderate positive influence showing the better fuel efficiency on highway raises prices. Mileage per gallon with the popularity negative impact -3, indicating that popularity does not significantly drive prices, while the engine horsepower moderates positive impact, more horsepower contributes to a slight price. Let us come to our Excel preview or Excel sheet. So you can see it here. Regression analysis, which are giving us yeah, this is okay. So it is giving us the R value, R squared value, adjusted R squared value, standard error, and observations. While regressions is also given, and if we talk about our third chart here or third table here, let me highlight it. Yeah, so I'm talking about this table. So it is showing us the coefficient value. So on the fixed value, we have been using MSRP at or how it is correlated with like engine horsepower, engine cylinders, number of doors, highway mileage per gallon city. So we have been like using this regression analysis is basically used for this case. Note this shows, you can also read it here, like on the bottom we have mentioned that this shows how much MSRP changes for each price or each unit change in the respective feature. While here key value is showing, uses to identify how the two data sets vary compared to the each other. If key value is less than 0.05, the feature has a significant impact on the price. While the T stat simplifies that two rows are samples from population from the same name if the value is greater than 2. For these results, we can conclude that increasing the engine horsepower, cylinder, highway, city MPG has a significant positive impact on the car price, while the number of doors popularity does not make a significant impact here. Again, we have been using it very easy chart that is easier for our stakeholder to understand. This is the bar chart. Let us come back to our presentation. The insight number two, average price of cars across different manufacturers. Average price of cars across different manufacturers. So the pivot table and bar chart. Basically, we have been using a pivot table is created to calculate the average price of cars from different manufacturers. The results are visualized using the bar chart to easily compare the prices across the brands. These are our bar chart basically. Inside this average price by manufacturer. From the chart, you can see that highest average price significantly above other manufacturer, indicating luxury and executives. So like Bugatti, that is not visible here due to lot of manufacturers. So the first being Bugatti here. So after Bugatti, we have Maybach, then Rolls Royce, then Lamborghini. So these are the premium brands with high average prices, showing the strong focus on performance and luxury. While we can see the Tesla and BMW, Tesla and BMW that are the mid-tier luxury manufacturer with competitive pricing, indicating technological innovation driving their value. Mainstream brands like Honda, Toyota, etc. These are lower average pricing, highlighting their focus on the affordable and mass market appeal. While the price distribution, if we talk about the distribution of the price, a clear gap between the high-end luxury and the mainstream manufacturer, reflecting that we have a different market segmentation. Let us talk this in our Excel sheet or show this in the Excel sheet. Manufacturer price comparison. So on the like x-axis or the rows we have been using all the manufacturer names and then we drop MSRP in the values column and then we change the sum to the average of MSRP. And then we selected this data to get the clear and easy like bar chart which is easy to understand for our stakeholder. We remove any kind of clutters. Use filters here. You can see it here. So if you want to see for suppose that we deselect all and we want to see for the Audi what is the for Audi manufacturer what is the average. So we can see here the value is average price is 54,574. So this is a feature of updated Excel which I liked it. Let us talk about our next visualization or next business problem. The relationship between the fuel efficiency and the engine cylinder. So for the fuel efficiency cylinders, we are using the scatter plot pivot table bar chart to easily compare the prices of brands. Here it is per gallon by engine cylinder. You can see, just give me a second. Yes, here you can see we have picked these columns like engine horsepower, engine cylinder number of those, high mileage per gallon, city mileage per gallon, popularity and MSRP. And out of there, we have been using number of cylinders on the x-axis and on the y-axis we are using the highway mileage curve. Again, a correlate function is used here, and which is you can see negative of 0.635. So correlate function is used between these two columns like cylinders and high mileage per gallon, and trend line is basically showing nothing significant drop. Like when we increase number of cylinders, the mileage per gallon is subsequently getting down. Here zero is showing us the electric vehicles, and they are having highest mileage per gallon, maximum I think 111. This is showing nothing but a technological innovation or improvement in our cylinders or our like car features, different car features like engines. The second is you can see it here. We have number of cylinders. Why I don't know. Yeah, three. The number of cylinders three. We have mileage of 29 and maximum being 43. Like that for four cylinders, mileage is 16 and maximum is 53. Again, a very high increase in high mileage per gallon with number of cylinders being 5, minimum being 18 mileage per gallon and maximum being 110. And this is, I think, almost equal to the electric powers. So there may be another advanced level of technological innovation, and then after that, it is subsequently getting down and down. So 16 being the max number of cylinders, and an outlier in this case also, which is extreme outlier from our data set, and only one kind of like cars we are having. Getting of like 16 cylinders and 14 miles per gallon, high mileage per. Talk about city mileage, that will be more lower, like 10 or 12 maybe. So this was our fifth visualization. Basically, strong negative correlation as the number of cylinders engine increases, miles per gallon significantly consistent. Declining engines with 4 to 8 cylinders. So steady decline miles per gallon. Reinforce the impact of inside on fuel consumption, while a high MPG outlier, a few vehicles with other with lower cylinder count, for example, 5 achieve exceptionally high mileage per gallon, suggesting an advanced engineering or hybrid technology. Zero cylinders indicate electric cars with high higher mileage per gallon, indicating the superior efficiency of electric power over traditional. So, providing repeated dashboard insight on distribution of car prices by brand and body style. So let us talk about our dashboard questions which have been asked. So first is distribution of car prices by brand and body style. So stat column chart with filters we have been using. We use prices to make the chart interactive, allowing users to explore the specific categories, and we have been including all of them. You can see it here, like this is this clustered column chart is showing the car prices by brand and body style. So for each brand, how many vehicle styles we have. If you talk about insights, so Chevrolet and Mercedes these offering and higher value. Diverse vehicle styles for the top brands like Chevrolet, Audi, have a wide variety of vehicle styles such as the sedan, pickup, SUV that are contributing to their high performance. The very dense have the higher price but cheaper models. If you have a luxury brands like I would like to show you a very Six 3,009, sorry, it's not 6 lakh, it is 6 crore 53 lakh, I think it's 65 crore. Yeah, so I'm so sorry. This time, let me come back with our pivot table. We can justify this. So, sum of MSRP. What is the sum of MSRP? They are had MSRP is somewhere. So this is very high. You can see this number is very very high compared to others. Like if you talk about Dorge, overall they are making a very good profit. Overall, they are, they are having a lot of brands. Like vehicle styles, there's a lot of vehicle styles. You can see it here for GMC the same. But for Lamborghini, you can see it has only two vehicle styles, and that is street domestic. That is not but again, custom market is focusing on luxury brands. So it is using the slices here, which is very useful. So you can select multiple. First, we select our 2D edge. Suppose we want to see our for the vehicle styles only. Uh, just a second. Yes, for the vehicle style only four. That is Ford Yaris UV, hatchback, crew cab pickup, and regular pickup. We are focusing on interested in seeing this pattern. So we can drill down or we can filter it here. So we can see whose are the brand which are manufacturing these vehicle styles. So you can see Chevrolet initially it was introduced with almost making all the vehicle styles and that is also making this vehicle. Still their some of MSRP is high. Because second is GMC having all these vehicle styles. Then Ford, Toyota. You cannot see luxury like luxury brands here. You cannot see. I cannot see it here. So for the time, clear all the filter. The same thing we can do with the brands. If we are interested in not seeing the Volvo, we can deselect it. Or if we select multiple, then we can see for the Tesla or Suzuki, or we can compare them at a time. Like what is the sales for Ford year ago in the Suzuki, like for the 700, I think 31 crore, 3 lakh 17,000, and for in the Suzuki, it's so you can see all this. For the time now, I'm going to clear all this, right? So let us come back to our presentation. So I will discuss all these insights with you. Second insight I would like to discuss for the dashboard insight two, that is brand with the and highest and lowest average MSRP by body style. So we have been using a clustered column chart to show this highest and lowest average MSRP by body style. This chart compares the average of MSRP across the brand and the body style that allows users to identify which brand and styles are most and least expensive. So you can see it here. I have only showing us what is included, that is the highest and lowest brands with average MSRP. Like average is high or either low. So for the high, we have having the Bugatti, that is extreme high compared to all of them. And then the climb being the lowest, which are having I think three seven kind of body style. So Bugatti dominates coupe, like coupe style has the highest performance started by the large margin, reflecting its status as a ultra luxury brand focusing on high performance. Plymouth represents low-end pricing, such as the hatches, sedan, and minivans, have significant lower MSRP, indicating a focus on affordable or mass market vehicles. It is focusing on a practical wise, the huge disparity between the brands. The chart indicates a stark difference between the luxury and budget brands, with being vastly higher Plymouth's offering. This insight shows the contrast in target markets, with Bugatti focusing on exclusive luxury, while Plymouth offers more affordable and practical. Let us see this in Excel. So high. So you can see it, like we have been using again pivot table. In the rows we have drag and drop make and vehicle style, and on the values we have been using the average of any style. And as you can see, we can set the pivot table from here, more sort options, ascending like manual. We have been using the vehicle styles in from highest to lowest, which and then we are using the column chart. Again, we have used the vehicle styles for the vehicle styles and make the filters here. If you or with the sisters who would be interested in seeing this filters or invest, he or she can easily filter it out here. let's come back with the next dashboard insights, that is the impact of transmission type on MSRP across the body style. So what is the impact of transmission type on our MSRP or across the different body styles? So for this we are using a scatter plot to show the relationship between the MSRP or transmission type with different symbols representing. Here it is. You can see here it has for each row we have different colors of scatter charts. So each color or each different color is showing us the body style, right? So basically we have the transmission type like automated manual, automatic, direct drive, manual or manual. Let's stop this in our Excel sheet. Yes, I think it should be visible. Okay, here we go. I know. So the transmission type is here. Sorry. So the transmission type and automated manual. You can see in transmission type we have drag and drop. In the pivot table, so is similar. So in our pivot table we have drag and drop. So when we fill this here, the vehicle styles and in our columns we have drag and drop the transmission type and then use an average of MSRPs, right? And you can see that the scatter chart is not able to create from the pivot table. So in pivot table any chart, so we have to copy all these columns into pieces and then we have been using this chart. So for automatic, automatic, direct manual, or unknown, for all these transmission type, we have been seeing this scatter chart. While stream outlet has been here, like for the automatic manual 4 foot, point like 2 for the vehicle style 2. Like average MSRP being for the coupe is for the transmission type like coupe or the automated manual is 2,45,977. The second highest being 1,29,082. So this is it. This is when this, and again we have been using another scatter chart, that is MSRP by transmission type. So this is easy to create because it does not includes any pivot table or neither of any calculations. So on the x-axis, which is showing us the relationship between the MSRP versus transmission time. Again, you can see it's almost same, right? And the filters have been added here. Let us talk about the insights. I know that insights, what are the insights from this? So manual and automatic transmission dominate most vehicles with the lower MSRP under 50,000 features either manual or automatic transmission, indicating their privilege in affordable prices. High-end models have automated manuals. Vehicles with automated manual transmissions tend to have the higher MSRP solution that feature seems more expensive performance-oriented cars. While the variant MSRP is a body style, the relationship between the body style and the MSRP is not linear, with some body styles featuring both low and high prices varying across the different transmission types. Unknown transmission models. There are some high MSRP models with unknown transmissions likely representing a specialized or rare configuration. So this analysis shows how vehicle pricing correlate with the both transmission type and the body style, with high-end vehicles having sophisticated and transmissions. Right. Dashboard insight number 4. Fuel efficiency variation across the body style and model years. So for this dashboard, we are actually looking for the a line chart. We have been working for with a line chart. Why we are using a line chart? Because it is used to track the trend of fuel efficiency. Fuel efficiency here it means mileage per gallon over time for each body style, like how each body style is doing over a time in terms of fuel efficiency. Again, filters have been used to explore the body styles or model year. So here we have fuel efficiency variation across the body style and the model year. Average of 80 miles per gallon and the average of higher miles. So we have included both these two like columns here, and you can see that there is a positive correlation between these two columns. For sure, highway mileage per gallon is high and that is very practical, while city mileage per gallon is low. On the x-axis, you can see we have the 2D hatchback, 2D SUV, which is representing as the vehicle style, and also yes. So for year like 1919 to 2014, what is increase or decrease in our fuel efficiency? So we can see in so for better analysis, I would like to take this fuel efficiency trend. Again, we have been using a pivot table. We have been making it larger to understand. Right. So in year 1990, the average city mileage per gallon for the 2D hatchback model found to be 22, while the while the highway mileage per gallon found to be 30. Then it then it goes down in the year 1992. That is goes to the 22. Initially it was 23, but it goes to the 22. Subsequent, there is a down in the highway mileage per gallon from 30 to 27. Then it goes down, and I think minimum fuel efficiency in year 1998 with the mileage of 17.2. This gone ups and downs, and finally the maximum mileage it was providing in year 90. Sorry, sorry, year is again here. Yeah, uh, highest city miles per gallon for the 2D hatcher is found to be 28. Is found to be 28 in year 2040. That will, according to this data, the latest data. So for each similarly, we are having each vehicle style here. You can check it out for 4DR head check for vehicle style. We can again check the highest of miles per gallon for the highway. That is 40. Again, as I talked about the filters, so no need to add another filter because it's already given as the filter. So again, you can filter it out here or here. So this has been inbuilt added in this Excel sheet. So let's come back to our presentation. So talk about the city and highway source trend over time indicated improvement in fuel efficiency for the mass vehicle types. Higher mileage per gallon is consistently higher than the city mileage per gallon is expected due to the more consistent fuel and fewer stops during the high significant dips in city mileage per around certain years, particularly 2014, suggesting regularity of market change of efficiency. Some vehicles may use the approach more volatility of the fixed balance for the 2013, which may of hybrid or more fuel high versus highway difference. City versus highway difference. The gap between city and highway miles per gallon remains relatively consistent across most vehicles, but for larger vehicles like the trucks, vans, difference becomes more pronounced due to the less efficient nature of these vehicles in the city driving condition. Talking about our last slide for this project, this analysis is the dashboard inside number 5, that is horsepower, miles per gallon, and price variation across the different brands. So we have been using the bubble chart to represent a relationship between the horsepower miles per gallon across the different car brands with the bubble in the different car model size representing the price. So very interesting include this, like deleting the chart, again making the chart, making the figure what's the what's the or where should I place the names, colors, or what should I put in the x-axis, y-axis. So I did this chart, making this bubble chart. So let us talk to this in the our. You can see that we are using the pivot at row level. We are using the all the and average of engine horsepower we have been using in the values like engine horsepower, then average highway miles per gallon, and the average of emission. We found that we should be including the highway miles per gallon because we do not have to add all things like city highway miles per gallon. So we are using the average of highway miles per gallon here. And on the x-axis, we have been using the engine horsepower. Again, I have identified the colors. So for the green color, it's showing like A580. with the engine horsepower 144 to 333. So I have colored in green because with this engine horsepower, they are giving us the good or the average highway mileage per gallon. So when we move after that, like from 400 to 600 or yeah, 400 to 610, we have some cars like Ferrari, Rolls McLaren, Lamborghini. Whose like average mileage per gallon is not high, but their prices are high. These are luxury brands focusing on like profit or luxury brands, luxury parts, luxury items. And then we have an extreme outlier here that is Bugatti. So Bugatti, I had already discussed this, like Bugatti with 1001 engine horsepower. Their price is almost 17,57,224, and their high mileage per gallon is lowest, that is 40, while F580 is dominating the data set. So let us talk about the insights. What are the insights after drawing this? So summary of the insights from the scatter plot: highway horsepower leads to lower fuel efficiency. Luxury and performance brands like Bugatti, Ferrari, Lamborghini have high horsepower but lower mileage per gallon. Bugatti is very popular with around horsepower and very low mileage per gallon figure. Performance brands like F5, Alfa Romeo, Honda, and Volkswagen have fuel efficiency between 33 to 37 and low between 200 horsepower. So the middle tier brands, BMW, Audi, Cadillac, balance horsepower 200 to 400 horsepower is the moderate mileage per gallon 25 to 30. So that is it. This was all. This was all about our project, and this is the basically the contact details. If you need any further analysis, contact my email, business 4. So thank you once again. I would like to extremely extend my heartfelt thanks to the Trinity for providing me with an opportunity to work on the interactive automotive data analysis project. This experience has greatly enhanced my skills in data analysis, advanced Excel segment, and dashboard creations. Again, the guidance that is provided, like how to do, which charts to use, right. So your guidance and support throughout the projects have been invaluable, and I'm confident that the learning from this experience will help solving the real world business challenges effectively. Thanks once again for this wonderful